this for year 10 methods pathways, we're going to look at question number 9 from exercise 1.2. So this is a worded problem. It's one of those problems where it's going to be an extended answer type problem. Okay, so we've got an egg timer. Alright, so an egg timer is there, and it's like an hourglass design. Basically, we've got sand at the top. When you tip it over, all the sand's at the top, and it slowly trickles down until all the sand comes at the bottom, in which time your egg is ready. So they've given us a graph of the relationship between the grains of sand on the top of the hourglass and the time. Okay, so obviously at the start, how many grains of sand are in the egg timer at the start? When t0, meaning no time has passed, we have the full amount of sand, which is 4,800 grains of sand. So 4,800 will be our answer, grains of sand. How many grains of sand will be left in bulb after 2 minutes? So after 2 minutes, let's look at the graph. So after 2 minutes, it corresponds to 1,600 grains of sand. So after 2 minutes, 1,600 grains of sand is still left at the top of the hourglass. Find the gradient of this line by identifying 2 points passing through. Okay, so I'm going to choose 2 points. I want to choose 2 easy points to read. So that's an easy point because that's like essentially like the y-intercept, and this is the x-intercept. They're both really easy points to read. So that point is 0, 4,800. Remember, you put the x value first, then the y. And here is the point 3, 0. Okay. So we need to find the gradient. Okay, so if I use the m formula, m is y2 minus y1 on x2 minus x1. My y2's 4,800 minus 0, and my x2 is 3. Oh no, it's 0 minus 3. So you got to get the order correct. So at the top we have 4,800, and at the bottom we have negative 3. So 4,800 divided by negative 3 is negative 1,600. Okay, that makes sense because gradient, as I said in class, is a rate. Okay, so what's the rate in this case? So the negative gradient is telling me that we're losing 1,600 grains of sand per minute. So can you see that that's a rate? Grains per minute. So we're losing 1,600 grains per minute, which makes sense. And that is confirmed by the shape of the graph. It's going that way. Okay, remember, if it goes this way, it's negative. This way, it's positive, and we've got this one. Okay, so it's negative gradient. D, find the rate of change of grain of sand with respect to time. In other words, what is the change in number of grains of sand at the top bulb each minute? So it's rate of change, so 160 grains per minute. So again, it's a rate. What does the negative represent in your answer? So in C, so negative means we are losing 1,600 grains per minute. So this is what the negative represents. Write the relationship. Write the relationship or rule to find the number of sand grains left in the top bulb, S, after t minutes. So what they're essentially doing is write a linear equation describing what's happening. Okay, so remember linear equation, we're all familiar with y equals mx plus c. Instead of y and x, they're using s and t. So which one's my s, which one's my t? Let's look at the graph. So the graph, the y-axis is the grains of sand. So it's the s instead of y, and the t instead of x. So mt plus c. So all that's different, girls, is that one is y and x, the other is s and t. Apart from that, it's exactly the same thing. We just labeled it y and x differently, okay, to relate back to the context. So what is our gradient? Our gradient is negative 1600. T is the same as x, so you leave it alone. And what's our y-intercept? Okay, let's look at our y-intercept, or our more correctly to say, what's our s-intercept? Our s-intercept is 4800 plus 4800. So this is how you write a relationship, basically. We know the gradient's negative 1600 and we know the y-intercept's 4800. So it's exactly the same as if you would do it as y equal y and x, but instead we're using s and t. What are the restrictions on the values that t can take? Okay, now what that means is, would all values of t make sense for this graph? So if I were to go to the negative t region, so negative 1 minute, negative 2 minutes, would that make sense? No, because even if I extend the graph beyond what it's drawn here, it wouldn't make sense, because that means you have negative time. That doesn't make sense. Nor would going beyond t equals 3 minutes make sense, because once all the sand goes down to the bottom, it wouldn't make sense to have negative grains of sand at the top. Okay, because that's essentially what it's saying. If we extend it beyond 3 minutes, the graph wouldn't make sense because you'll have negative grains of sand. Okay, so what restrictions on the values can t take? T is between 0 and 3 minutes. So it only makes sense between t equals 0 to 3 minutes. And this is something you've got to pay attention to. When you're doing questions with regards to context-based questions, so with real life, you've got to consider, in real life, would that make sense if it goes beyond 3 minutes? No, it doesn't. If it goes before 0 minutes, would that make sense? No, okay, because it only operates between 0 to 3 minutes. So hopefully that gives you an idea like how to tackle these problems. So I want everyone to be really comfortable with, instead of using y equals mx plus c, you can use other letters instead. Okay, it's the same thing. You're just finding still subbing in the gradient and subbing in the y-intercept to get the equation.